Welcome back. This is the next video in our DMX lighting series. And this one we're going to talk about the addressing. Now, I've decided to break up the two addressing lessons into two different parts. Ethernet addressing, which is for a network, and DMX addressing, which is for the DMX lighting network. So we're going to cover first the Ethernet part, how you put something on a network. And this doesn't really apply just to DMX. It's for the network in your house. It's for your network in your business. They all work this way. I thought I'd start out with a picture of my son. First year he wanted to be lit up, so I took a 12-volt battery from a drill and wired it to one of those dumb RGB ribbons that I've been showing you. And we ran it inside and sewed it inside a suit of mesh fabric. And then I forget what he called this. And then the next one, he wanted to be Stickman. So we thought it would be funny. So I took plastic tubes and I connected them with little pieces of ring or string or something like that. And we sewed it or affixed it to him, and he was dressed all in black. And this was the funniest thing. When he walked down the street, you could just see a Stickman walking towards you. Pretty simple stuff. It was that super simple, cheap $20 RGB dumb controller, and he's got the remote in his hand, and you can see the controller hanging here from his belt. And he could change the color, and some of those cheap ones come with patterns as well. So I thought you'd enjoy the picture to get started. So let's jump to it if you would like, and we will get to how to set up your home network. So this was where we left off with how we were connecting our controllers to our network. So we're going to be covering this piece of our lesson today, how these things can get connected. So I've drawn up a little diagram here. Let me go down to this one to super simplify it, to make it simple for you. And I throw this little bit at the bottom here just because I've been in networking for multiple decades, more than that. And I know somebody out there is going to say, well, that's not exactly how it works. So that part's for you. The rest of you can ignore it. But this is your network. We're going to draw your network, whether it's wireless, wired, at home, as a straight line. It's just a line. This is your network. And the things that you have connect to it, whether through wireless or through a wire that you physically connect in. Now, your computer connects to it probably through wireless. Another computer connects to it probably through wireless. A printer might be wired into it. You could also have, which I have on one of the other slides, a phone connecting to it wirelessly. And then what we're going to be doing in this lesson is connecting our DMX controller to it. You also have a router, or it's also a firewall. It's also a switch too. So some of these plugs, if these were actual physical plugs, might actually be plugging directly into it. We just represent it this way, when we draw it. Okay, so everything that's connected to this network, including the router itself, has an address. It's the only way that we can pass data between them in these little things called packets, and know who it's going to and who it's coming from. So if I want to print something from my computer would have to talk from its address to the printer, and the printer would have to talk back until its print job's done. If my computer wanted to talk to the internet, it would talk to my router. This is known as a gateway or default gateway device. So a gateway means, where do you go? A default gateway, where do you go and send data to when you want to send it to some place that's not on your network? It's not on this street. And that's our gateway here. So we're going to start out by talking about what the addressing looks like here. And there's basically two main components we need for an address. So we have them over here, and I'm going to actually type alongside of them. This one is referred to as the IP address, the top one. And the bottom one's referred to as a subnet mask. And they have a purpose. So much like when you consider your postal address for your house, you have, and we're just going to ignore the city, state, and zip. Just take the street and the number. Think of this line, this network, as the street address. So I live on Enslow Lane. Okay, that's the name of my road. Now I'm number house 8. Now there's other houses on that road, but they're not mine. So you can kind of think of these as all the houses on the road, and each one will have a unique part of its address that's its number, and a common part of its address that's its street address. So if this was 7 Enslow Lane, 8 Enslow Lane, that'd be mine, 9 Enslow Lane, 10 Enslow Lane, 11 Enslow Lane. They all have the part of Enslow Lane in their naming convention, but they don't have the same numbers. That would be kind of confusing for the postal delivery people. So we're going to take a look at those numbers. I'm going to show you where to get these numbers from later. But let's assume for now this is your IP address. Actually, no, we're going to show you where that is now. I'm on a Mac, so I'm going to go into my settings. I won't even do the command line stuff. I'll go into here. I will go into my network settings. And in your Windows boxes, it's Control Panel. I'll go under Advanced here, and I'm going to look at my TCP IP addressing. And you can see my numbers are here. I have an IP address of .100, or 192.168.251 address. This doesn't match on my screen, but that's okay. Here's my subnet mask. There's something called a router. Sometimes you'll hear it called a gateway, and a lot of times you'll hear it called a default gateway. So 3 basic pieces of information that we need. You can find this in your control panel as well, and on one of the screenshots, I show you the command line way of finding it. So what I'm going to do is just show you how to break down an Ethernet address. The addressing is referred to as TCP/IP. TCP/IP is the language that we speak on this network. This is called Transmission Control Protocol, Internet Protocol, but you'll often hear it just called IP addressing, okay? But the actual full protocol is TCP/IP. This is pretty much the standard protocol that's used on the internet and on everyone's network just about everywhere in the world. It's not a standard that's required, it's a de facto standard, meaning most people use it. There are other protocols, but this is the one that you're going to find just about everywhere. So when we look at TCP/IP addressing, the 2 parts I'm looking at right now is the IP address itself that your computer has in the subnet mask. And much like a street and a house number, the subnet mask is going to help us tell what part of the IP address is the name of the street and what part is the actual individual's unique number. And why do we have to do that? That's because it's not defined what part of this number is my street address. My street could be 192.168 and my house number could be 1.10. My street could be 192. My house number could be 168.1.10. Or my street could be 192.168.1 and my house number could be 10. You really can't tell just looking at this. And actually, this is actually processed and stored in binary, which means you can actually divide these numbers in half, which gets really confusing. We won't go down that road, but basically the subnet mask allows us to define what out of the IP address is our street and which one is our unique number. And that's important because when we put our DMX controller on our network, we're not going to want to have it get a dynamic and automatic address from your network the way your phone does when you connect it to the wireless or your computer does when you get to the wireless. Because we might get a different number every day, but you don't know that because nothing's connecting to your phone to use it. Your phone's connecting to other things to use it. For example, if you come home and you get on your wireless, you're really just going to use the internet and the printer. But what happens if the printer's address changes every day to something else? You have to set it up every day. So when it comes to resources like a printer, a controller, a server, or a router, we don't want them to change their addresses. So what we'll tend to do is give them static addresses. Static address just means we typed in an address. We don't let it automatically get one. And we'll show you a little bit more on that on the next slide. So we are going to take the IP address we have and the subnet mask, and in this next illustration, this is just written out a little bit differently for the sake of illustrating what a mask does. So instead of writing 1, I wrote 001 to make it 3 digits. Instead of 10, I wrote 010, so give it 3 digits to make it easier to see the subnet mask against it. So what the subnet mask does is anywhere there's a 255, that means the number above it is part of your street address. So we see very easily that our street address is 192.168.1. That means every computer on here is going to start with a 192.168.1 address. We also see that there's zeros in the last, after the last dot. These are all zeros, which means this number is going to be unique for every single device. Usually your router will be .1, and then you can, the router in your home or a server in your network will have a range of these to give out to devices that connect to it that we want to be dynamic, like a phone or a computer. And I'll show you that's called dynamic host control control protocol and configuration protocol, DHCP, and it's going to give addresses to computers and stuff as they connect that are dynamic. And we'll show you where that range is. And for these type of things, we're going to want to statically put numbers on them to make sure they have unique addresses but never move. Things that are dynamic might have their numbers change day to day. So the red section here kind of shows you that the 255s tell you that the 192.168.1 is your street address, and the zeros tell you your house number 10. Now, for those of you that are networking people and want to know why 255 is the highest number you can have in any one of these sections and how it can divide, what it's really doing is, if you took all these numbers and you wrote them in binary, the top number being the IP address, the bottom number being the subnet mask. The subnet mask is all ones from left to right. It can't skip any. And wherever the ones stop, no matter where they stop, that means the numbers above them represent your network, and the numbers to the above the zeros represent hosts. Most of the time in most networks, we break it on the dot so that we can say, oh, 255, that 192 is part of the network. 255, that 168 is part of the network. 255.01 1 is part of the network. So my network is 192.168.1, but I don't have to. I could break it in the middle if I wanted to. Again, that section there is just for those bit heads that want to be specific about how a subnet mask actually defines what part of the IP address above it is part of the network. So now that we understand how to define our network and what our house number is versus our network, we're going to go on to the next slide, which is to switch this and to show you how it might look on your network at home. So a lot of times at your network at home, your router, aka your firewall, is also a dynamic host configuration protocol server. So it means it's going to give out IP addresses. So you might say to yourself, well, what addresses does it give out? Well, it depends on what you gave it. So let's just say somebody configured it to use a pool of .100 through .150. So that means that it has these numbers. So anytime a computer, a phone, or something boots up and connects to your network, it gives it one, and it gives it to it for a certain amount of time, let's say 1 day. And at the end of a day, you got to ask for another one, and it gives you another one. And it might be the same one, it might not. The Dynamic Host Configuration Protocol, DHCP clients, numbers may change from day to day. I've actually made a mistake here, and this would have to be a different number. So it might change different from day to day, but it doesn't matter because we're not connecting from the smartphone to the computer, vice versa. We're connecting from the smartphone to a printer, or from the computer to a printer, or from the computer to a router. These are the things we don't want to change their IP addresses. So the router almost always is a .1 on your network, whatever it is. It's almost always the lowest number. Sometimes it's the highest number, and in my network, it's neither. But this, when we looked at my screens, my settings here, let me go back to my settings and back into networks and under advanced. When I looked at my addressing, my router is .5 on a 192.168.250 network. My computer is .100. So these are the 3 bits of information that you absolutely have to have. There's some others, but we won't go into those and what they're for. So in this network, .1 is the gateway. It's the IP address of the router, and by default, this gateway serves as a way to get to the internet. The internet would be out here. So anything that needs to talk to the internet sends their data to this, and it sends it out to the internet and returns it to the computer or a printer or whatever when it gets a response. This is also your DHCP server, and it has a pool. Now, a lot of people don't know how to go into their routers, connect to this address through a browser, log in, and see what the range is set to. So if you're doing lighting at home and you don't know what your router's DHCP pool is, the best thing is, if you have to guess, go high. So for example, on my DMX controller, I may configure it on a high number like 200, 201, 202, 203. It's a pretty good guess that if you go that high, you're not going to clobber anything else, because you can't have 2 devices on the network with the same IP address. They have to be unique. That last number has to be different on each one. But if you go high, it's probably not inside the pool range, means that this won't give it to somebody, or it's so high that you'll never have that many devices on your network in 1 day. So you can see here my example, my computer. This computer here picked up a dynamic address when it connected to the network of .101. This one got .102. This phone got 103. Our network is 192.168.1.0 by defined by the subnet mask. I've statically set my printer to .10. This is one of the things that people don't tend to do. They just connect their printer and follow the instructions the printer vendor gives you. And it actually works a lot better if you keep this at a static address. In my DMX controller, I give it an address of .200, and my next one was .201 and 202 and 203, etc. The IP addressing basically works down on just about every home network, and it doesn't matter how you're connecting wireless or wired. The media by which you connect doesn't play a role in addressing in this case. So this is the fundamentals of how to get an IP address on your network and how to decide where you're going to put things. So hopefully that explains to you what a subnet mask, what an IP address is, and how things have to be unique and why. Let's go on to another section here that shows you a little more illustrative of the same thing. This is a wireless router. We plug some things in. You might have this router. You see these 4 ports here? They're yellow. A lot of routers have a switch. This is a switch. Now what a switch does is think of it like an extension cord. You have an outlet. You plug an extension cord in it. Now you can plug a whole bunch more things into the same power outlet. That's all a switch does. So these routers have a 4-port switch or a 5-port switch or an 8-port switch in the back. And you can actually connect that to yet another switch to get more ports if you need it. The other interface is the routed firewall interface. So there's always one off by itself. That's the internet side. And that is, you kind of think of this as, it's actually 3 devices wrapped up into one. It's an access point for wireless. It's a switch on these ports, and it's a router that gets your data in and out of the network. And it's actually 4 devices. It's also a firewall. It has rules to block things. So what you need to know is simply this. The switch ports are the same. Doesn't matter which one of these you plug into. You're on that 192.168.1 network. And things can be plugged into any of these ports, and they're equivalent of something connecting to the wireless antennas in most cases. So whether you're on the wireless or you're wired, it doesn't matter. You're on the same network, okay? And this illustration shows you a couple DMX controllers plugged in. This one is how mine are done this year. This one is how mine were done in past years. And again, I had a lot of problems with these little switches getting too cold. One last thing I'm going to add down here is the internet. Obviously, this is a public internet up till it hits this port, and then this protects you from a firewall perspective. It protects people from getting into your network without you wanting them in. It allows you out, but doesn't allow anybody in. So that's the red network. The blue networks are private. Now, what I've listed down here is some common numbers that you will find on your network. They're not all 192.168s. They might be 10 dot somethings. A lot of Comcast SMC routers and stuff start 10 dot. I think a lot of Netgear start 10 dot. 172 is a lot less common. It'll be like 172.16 or 172. I think the highest number you can go to is 31. But these numbers, the reason I give them here, actually, to be correct, that should be 16. To be correct, the 172, the 10, and 192.168, these numbers are not valid on the internet. That means if I go and try to connect to something at 192.168 on the internet, before it goes out this way, or if I configure my router to send it out, the internet provider is going to throw it away because these aren't legal. You can kind of think of these like saying, some false address. I want to go to, some other dimension. So that's why they're used internally, because they kind of give you some other levels of protection, because nobody can actually try to talk to your computer directly because these can't route on the internet. So when you go to configure your network and you want to figure out what your network is, I put these in there just so you know. And again, this number might vary. I think that's why I left this next. You're going to probably have one of these numbers there. If you have a number that starts with 169, that basically means that something's malfunctioned and your router never gave your computer a number, or your computer never actually connected well enough to the network to get a number. 169 is basically saying, I've asked for a number like 3 times. Nobody gave me one. I'm going to make up a number. And it's not valid anywhere. It doesn't get you anywhere. It doesn't do you any good. But just if you see a 169, that's not a valid number. That's more like an error. And this is how your network will look. Let's break it down here and tear some of this off. And just go to the, take the internet away. This is to illustrate what DHCP is. Dynamic Host Configuration Protocol is basically the ability of something to give out network addresses on your network for you automatically. And obviously this happens all day long. You go to Starbucks, you connect to their wireless, your phone or your laptop has to get an address. Something on their network gives it to you, and then you can use the internet. Same thing on your home network. You go home, you connect to your device, you get an IP address. Now you're automatically able to connect to the internet. Wow, it's amazing. Well, there's something doing it. In a business, it's almost always a big server somewhere. In a home network, it's almost always a little internet wireless router that you're using. And it has a range that it can give out. In this example, I used this particular Linksys, and it has a range of 2 through 100. So that means it's .1. Then any device that connects, it starts giving out numbers, starts with .2, the next one it gives .3, the next one it gives .4, and it gives them to the devices as they ask. And it also sets a time. You can use this for 1 day, or typically 3 days is a common one. And at the end of 3 days, you have to give it back, and you have to ask for another one. So it's important to understand that the DHCP is coming out of this. In the case of our controllers, we don't want them doing DHCP, so we're going to actually configure the IP address, subnet mask, and default gateway on the controller itself statically. So how do you do that? Well, when you plug this DMX controller in to your network, it will get a DHCP address. Now we just got to figure out which one it got, and you try to browse to it. And I'll cover that a little bit more in the configuration of the controller video. Then you would actually connect to that IP address, be able to see the controller, and configure it to be static rather than dynamic. And I'll show you how to do that in that video. This slide is really to show you a couple more things. Just to define the IP addresses, our unique IP address in our network, as we discussed. The subnet mask helps us to define what part of the IP address defines the house and the street. And the default gateway, which would be this router in this case, tells your computer where to send data when it needs to get to a place that's not on the local network there, like the internet, like Google or Bing or Yahoo or something like that. Also, here are a couple examples of how we would type. Let me see if I can zoom in on this. You can type ipconfig at a command prompt on a PC, and it will give you this information so you can determine what your router is, what your subnet mask is, and your actual individual address for your computer. And the command's very similar on a Mac. It's ifconfig, or you saw me go into the settings there. Very easy to get to that as well. So if you have to determine what that is, one of the reasons you like this ipconfig command is it tells you the default gateway is 192.168.1.1. So in my case, mine was, let me do this. Well, actually, it's a bad example because I don't have a good firewall to show, but that means you can put this into a browser, this default gateway, and either HTTP or it might be HTTPS to it. So it's HTTP:// and then that number, 192.168.1.1. And you should get a web interface of your router, basically a web console into this to configure it as administrator, and you'd have to know your username and password or look on it. Maybe somebody stuck it on there or set it when you bought it. It could be the default of admin1234 or admin or admin password, but that's how you manage this device as well. In this example, the network addresses, we're going to say it's based on this, it's a 192.168.1 dot. The X representing the host address, as we illustrated on the last slide. When you look at the whole network, the valid numbers in this host part where the X is 0 through 255. However, 0 and 255 are special numbers. You can't use those. 0 represents the network. It's kind of like if you put an address down for someone to send you money and you said, I live on Enslow Lane, you didn't put the house number down. Well, that's not valid. So 0 is not valid. And 255 is a special number that's called a broadcast. If you sent mail to a broadcast address on your street, that means it's mail that would go to every house, all the houses at the same time. So we can't use that either. So I'm listing this as the usable addresses are .1 through .254. Again, .1 is usually your router. That means you can use 2 through 254, and in this example, the router's been configured to use 2 through 100 as its pool to give out for dynamic clients. So I would want my DMX controller something above that, not in that pool. That way this thing doesn't give someone an address that's already on this. And then the subnet mask is listed there, and the default gateway is listed there as well. So hopefully that gives you a little more illustration on how to get some of these things out of your computer. Let's break it down a little bit simpler here, and here's an example of a network where your router has 3 wires, one running to each controller and one running to your computer. And your computer is going to run software that's going to send data to the controllers, and that controller is going to send it out those inputs to the lights. So in this example, I've given this controller a static address of 192.168.1.254. I'm sorry, 250, and this 251. I don't list all the rest of the data, the default gateway, and the subnet mask. That'll be the same on all of them. But just to show you how you would do this in a simple format, how you would statically assign and what it would look like. So we're going to actually show you the screens for this in the next video. Actually, the video after that, because the next video is going to be DMX. So I'm just going to show you this slide. This one's coming in the next video. Let me just take a quick look here. Yep, this is coming in the next video, but I'm going to just show you a little precursor to that, which is that port that wires in off the network. That port right there is the one that's going to get the IP address. The rest of this stuff is addressed through DMX, and we're going to go through that in the next video. So that's where these each get their IP address. And of course, this is 3 illustrations of the same controller. These were 3 controllers on my network. They'd have to have different numbers, but we'll use this slide in the next video. So I hope you enjoyed this. I hope it gives you a little better understanding for how we're going to be doing addressing on the network. And whether you have DMX lighting or you don't, and you have controllers if you don't, you can actually go through this particular lesson and look at your network and take a look at things and how you're set up. You can actually use a web browser and hit your default gateway, and you would actually just put that. Let me just show you this. Let me open a browser, and I would just type in here. I'm going to actually, I don't know if mine will, oh, mine's a .5. And I have to continue to the website. I'm not sure it likes the, mine's kind of a goofy setup, but basically if you type that in here with either HTTP or HTTPS, you will get, let me see, let's do a Linksys. Router login. You will get something that looks like this. A screen that looks like this, and there's a bunch of tabs, and it lets you configure this device. This screen is configuring this device. You're connecting to it across the wire and configuring it. So you can put that right into a browser and get that. My network's kind of goofy, so I'm not going to actually break down exactly how it's set up, but most environments set up this way. All right, hope you enjoyed it. Let's see you in the next video where we cover DMX addressing. Bye-bye.